and DevOps and SRE, Site Reliability Engineering. Okay. So in this demo, what we're gonna do, we're gonna go over the course that we are coming up with. The Isha Training Solutions is coming up with, and we'll go over the course. And you can ask, you can understand the course syllabus and what you're expecting, right? We'll just go over the session on the regarding the course curriculum and what's the thought process of coming up with the course and how it's going to benefit all of you. Before I get started, I would like you to just confirm. Most of my folks who join my webinar or demo session are most from the performance engineering testing background, and they are looking to upskill themselves and understand the SRE and the cloud performance engineering scope. So is the same group joined here as well? Just you can just put it in the chat. Is most of the folks are from performance testing engineering background, aspirants? Would that be a right assumption? Okay, Akash says yes. Okay, Satish, yes. Okay, looks like yes. Perfect. Good, guys. So we are on the same page. Okay. So before I get started, let me introduce myself. Okay. So my name is Roshan, guys. I have been in IT in industry from last 16 years. I started my career with Java development, okay, and then I moved into performance engineering, where the crux of performance, the Java performance engineering, the Java coding lies, to optimizing the code, right? So that was the one of the roles that I have taken up for quite some time, 6 years, 7 years. But nowadays I'm mostly into this DevOps and SRE practices. I am the principal SRE with one of the reputed retail giants you can imagine. Okay, so handling trillions, like millions of users at scale, taking care of production reliability. Okay, so that's the difference between the performance engineers who benchmark the application and the SRE. In SRE basically looks into from the production point of view, making sure production is highly available, reliable, and secure, and those aspects will come to that. Okay, then I have spent quite a long period in the automation part, used various automation tools, like I have been used Selenium for the UI automation, then Python scripting, Shell scripting, Terraform, Ansible, like a lot of tools, right? On the cloud credentials, I am a multi-cloud solution architect certified, done certification in all the three major cloud service providers. I've been lucky enough to work in all the three, AWS, Azure, and GCP. Okay, so that's about me, guys. Part of my hobby. Sorry, a bit glitch. As part of my hobby, I like to share my knowledge and travel. Okay, so that's what I do. On my teaching experience, I have been teaching from last 6 years. I'm with Isha from last 3 years. I teach with other institutes as well, Intellipath, Eureka, Simply Learn. All right. So yeah, so I engage them there as well. Okay. So that's a background about me, everyone. Um, okay. So before I get started, okay, I always start with a question. Okay, I always start with a question, and I ask this question, and then we'll go over the something called software development and deployment evolution, how the software has been developed and deployed over the years, and then we'll look into the course syllabus, what it is in the course, what you should expect from the course, and what you will learn by the end of the course, and then follow by the Q&A. So that's how the session is planned. Okay, so let me start with the question, everyone. So you see there are four words that I have used here in the slide: DevOps, microservices, containers, and cloud. Right. So, and the question is, do you think the performance engineers are expected to know all of this as per the current market trend, as the industry is headed, where the industry is headed, and the way you may be looking into the interviews, right? Or right. So, do you think, guys, uh, performance engineers or aspirants of SRE? Do you think these things are important and must to have? Just your perspective, everyone. What do you guys think? Yes, no, no idea. Anything could be fine. Kishore says yes. Raman says yes. Okay. Guys, trust me, if you have been taking up interviews, you would know this what I'm talking about. Okay. This is gonna be the thing. Okay. When it will be asked. I'll tell you why. There's a reason for it. Okay. And I'll show you the next slide and you will understand where these things land. Okay. If you look at the software development and deployment, both over the years, right, you will understand where these four things fit in. Okay, let me, here you go, the next slide. Okay, if you look at this, so this is where it fits in. Deployed over the years is to think first, and then we started to test difficult architecture, and we did all the SDLC. End product that we get was able to remediate or was able to mitigate left for the things that I put there, because that's how DevOps is. Whatever the problem, the shortcomings of Agile were there, we are trying to solve the problems of Agile in DevOps through automation. We'll understand in detail. Okay, once we understand the DevOps, what it is. See, understand one thing. I'll just make it brief. When the code is ready, when the developer end goal. End goal is to deploy the code to the production. That's the end goal. But we do artifact jar file. We test, we do functional testing, we do performance testing, we do security testing, and a lot of time gets spent. Increase velocity of the product when the code is ready minimizes, and we're able to deploy the code in the production at the earliest. The DevOps, we are use Agile, but we automate the process so the time to release the product reduces, the release velocity increases. That's what we do in DevOps. Right? So that's on the development process. We have made a tremendous progress on the architecture as well. Earlier, we were dealing with monolithic applications, but nowadays, if you look at, we are dealing with microservices architecture. It's all microservices. Our monolithic applications are being converted to microservices, and the newer developments that is happening in the case of all happening in the microservices. I'll tell you one example of microservices. All the recent applications that you see, the Swiggy, the Uber, all those recent applications are being developed in microservices. The best part of microservices is that the one core functionality does not impact the core functionality of the other. Right? We interact through the REST API calls to Indigo, Air India, Air Asia. So many flight carriers, you book the ticket. Right? How it is possible? Do you think the Make My Trip has the database access of all Indigo, AirAsia? Like, do all the flight cat? Do you think that we have the database access? No, it's all through the REST API, because it's all microservices based architecture, right? So that's how the communication is happening, right? So if I tell you, let's say the Swiggy or Uber application, if a notification, there is a functionality called notification, which is at the top right corner. Whenever you book a cab or order your food, the notification, you get a notification that you have ordered your food or the cab has been booked, right? You get a notification. If I tell you, if a notification is not working, you will not be able to book your cab. You will not buy this. You see, it's not a good application at all. And that was the case with monolithic applications back then. It was so interdependent, tightly coupled. We were calling the functions from one module to other module. It was so tightly coupled in the case of monolithic applications, and that was the case. One functionality breakdown can bring the entire application down. But that's not the case with microservices. If Indigo server is down, it's not going to block Make My Trip making calls to AirAsia or Indian Airlines, right? All are microservice-based architecture, and we're able to book flights through API calls. It's not like the Make My Trip has all the database access. It's all microservices world that we're dealing with, right? And what brings us to the next topic. Where should we deploy the microservices? So we are breaking down the application from monolithic to microservices. Earlier, we used to use, back then, the physical servers when there was no virtualization in place. No virtualization, right? We used to deploy everything on the physical server. Then virtualization came and we created VMs, multiple VMs we could create. And we had this 3-tier, N-tier application. We used to deploy each one application on each server, right? Let's say I'm deploying app server. Let's say I'm using one VM to deploy my app server, one VM to deploy my web server, one VM to deploy my database server. Right? This was the case. But again, over the year, it was found that we are not able to utilize the resources, the CPU and the memory of these guys. We are wasting resources. So what was the next move? Next move is to containerize it. So in one VM itself, can I run multi-tier application? In one VM itself, can I create 3 containers where one container is my web server, another container is my app server, another container could be my database server? Can that happen? That in one VM, can we do that? Yes, it is possible through containerization. When we install container engine like Docker, we can do that. And when we split this, the microservices are the best candidates to be deployed on the containers. We are splitting the bigger applications to smaller applications, right? And we can deploy separately. One microservices to one container, another microservice to another container, right? And that's why we talk about Docker, deploying microservices. And when we have got a lot of containers, we need to orchestrate them. We need to auto scale in production. When the load increases, auto load balancing, auto self-healing, auto scaling, orchestrate them through Kubernetes, right? So this entire thing, right, from the technology perspective, I'm not talking from a performance at all right now. I'm talking from a just technology perspective, where we are headed, right? And we need to understand, because when the technology is progressing, our performance engineering skill set needs to get upskilled as per the current, how the software has been developed and deployed. So we need to have the thought process of a skill set upskill with that, right? So that's how the situation is. You guys able to follow me what I'm talking about? Any questions till this point of time? Anything you want me to repeat, or you could not follow? Are we good? Please give me a thumbs up, guys. Yes, no. Are we following things, guys?
Yes, yes, sir.
Okay,
So far,
perfect.
it's good.
Okay, good. No, others all good, right? Perfect. So now, next thing, right? Now, when it comes to where should we deploy? So first of all, see, to create VMs also, to create physical server, we need either you need an on-premise system or you need cloud, right? We need this. So earlier, back in 1980s, when you have a business idea like Amazon.com, you had no other option but to set up your own data center. Jeff Bezos did that. He set up his own data center to deploy Amazon.com website, but he did great. He While doing that, he got this idea of Amazon Web Services, AWS. He thought the whatever he was doing for his data center, the same data hardware software can be leveraged by others also, and that's what we are